Importance of the topic. Prediction of fatigue growth, crack growth rate (FCG) is an important problem in fracture mechanics, essential for ensuring the reliability and safety of structures subjected to cyclic loading. In this study, we want to present a comparative analysis between analytical models, Paris empirical law, and polynomial approximations of various degrees, and a model based on an artificial neural network in the task of modeling the FCG rate of titanium alloy. And the aim of the study is to evaluate the accuracy of the neural network and traditional approaches to quantitatively assess the accuracy of the model. The matrix of mean absolute error, mean squared error, mean absolute relative error, and coefficient of determination R squared were used. So prediction of fatigue crack growth rate. The problem of fatigue failure of structural elements is extremely relevant in the condition of increased attention to the reliability and
Could
safety.
you still open the increase the volume a little bit? For us, it's still very silent.
Sorry?
I mean that we still cannot hear you very clearly.
I'm not sure why. The problem of fatigue failure of structural materials is extremely relevant. Maybe something with internet, I'm not sure. But the connection is overall quite good here. So the problem of fatigue failure of structural materials is extremely relevant in the conditions of increased attention to the reliability and safety of structural elements in mechanical engineering, aviation, and energy industries. Particularly, classical analytical models provide acceptable accuracy in the middle range of the amplitude of the stress intensity factor delta K, but demonstrate limitations in describing the boundary regions of the crack growth curve. Therefore, to solve the problems of fracture mechanics, it is advisable to use neural networks to model fatigue process. I see that somebody has his mic on. Maybe it's better to mute because maybe of this. This is the reason. Could be the reason of bad uh, uh, voice. Prediction of fatigue crack growth rate (FCG). To evaluate the resource of components, fracture mechanics approaches are traditionally used, in particularly the dependence of the FCG growth rate delta A over delta N on the stress intensity factor range is used with stress ratio significantly affecting the FCG rate. The classical example is Paris law. However, it describes only the second part of the fatigue failure diagram and does not consider the influence of number of factors such as stress ratio R. In addition, okay. In addition to power law, the approximation of the dependence of dA over delta N on delta K using polynomials in logarithmic coordinates is considered. In other words, the curve log dA over dN base 10 is approximated as polynomial of log of delta K base 10. Polynomials of various degrees were employed for the study. Quadratic degree 2 denoted quad, cubic degree 3 denoted cubic, fourth degree deck, and fifth degree deck 5. So deck 4 and deck 5. Experimental data often show scattered. Traditional models may not be able to capture all aspects of crack growth. Neural network trained on large datasets can learn complex relationships and account for multiple influencing factors. So neural networks are inspired by human brain, and we have inputs. Here we have so we have dendrites and axons, and here we have activation function. This gives us the output. Here we have a summation. So artificial neural model is taken from hiking 8. The algorithm of neuron function is based on the following formulas. We have net JI, it is a sum based on AVIJL times XIJL. We have out signal, it is actuation function net JL minus theta J, and XIJL plus 1 is out J. So we have here an inputs, we have here weights, we have here summation. I see that somebody has the microphone, which is turned on. Maybe it's better to mute. How do you think? Okay. So model accuracy assessment matrix. We have the following formulas to obtain mean absolute error, mean squared error, mean absolute percentage error, and R squared. The mean absolute error reflects the average absolute deviation between the predicted and actual signals. It characterizes the typical magnitude of the model's error regardless of its direction, provided an intuitive estimate of accuracy. The mean squared error MSE emphasizes the impact of larger deviation by raising the error to square. This makes the metric sensitive to abnormally large differences between predicted and actual values, allowing you to identify situations where the model produces significant errors. Now, the mean absolute percentage error mapper determines the relative accuracy of the focus by calculating the average error as a percentage of the actual values. This matrix enables to evaluate the accuracy of the model regardless of the scale of data and compares the results between different experiments. And the coefficient of determination R square reflects the proportion of the variance in the actual predicted values that is explained by the model. A value close to 1 indicates high accuracy and good agreement between the forecast and the experimental data. So experimental data for FTG analysis were taken from literature. The study used a multi-layer neural network and MLP with one input delta K and one output DAODN with two hidden layers of 256 neurons. Each in particular, the particular growth rate is modeled by neural network with stress ratio R equals 0.3. During training, the data set was divided into two unequal parts, training and test samples. So the sample contained 154 elements, and it was taken from paper Liu et al. 2023, of which 70% were randomly selected for the training set, and 30% were left to relate the quality of the prediction. So this was the test trend split. On this figure, you can see the graph of the loss versus epochs. In other words, shows the dynamics of loss function during neural network training at this stress ratio, the given stress ratio. It can be seen from the graph that the training validation loss is being increased in the course of epochs. Figure 2 shows so-called actual versus predicted graph, and this line, the bisector of the first coordinate angle, shows the perfect prediction, and if points are close to this line, so this means that the results are quite accurate. This is the predicted and experimental values of FTG rate obtained by neural network methods. So here you can see the dependency in the day over delta n in millimeters by cycle per cycle versus delta k as it is MPI square root of matter, particular growth in log scale. The blue line shows the experimental data, and the red line demonstrates predicted by neural network. And we also predicted FCG rate using, so we built also analytical models by employing various polynomials of various orders. So you can see on this graph experimental data, Paris law, and various degrees of polynomials. Here you can see R squared. It's quite high. And it's been increased with the degree of polynomial. Okay. Now, here on this slide, you can see the expressions for our analytical models, uh, the coefficients, namely the polynomials and the coefficients of the polynomials. Okay. So models and versus prediction errors. Table 1 shows comparison of accuracy of models for predicting the FCG array. Here you can see that degree, for instance, degree 4 of polynomial shows almost the lowest error, and but it's comparable with degree 5 polynomial, and multi-layer network shows bigger error. So this could be, so in this case we can either choose by if we use analytical models or neural networks. So in this but if we take mean absolute errors, so it is quite big here, so there is always a room for improvement. And finally, I would like to come to conclusions. Polynomial models have demonstrated that by increasing the degree of the polynomial, it is possible to achieve accuracy close to that of a neural network method. The results show that both approaches, namely classical analytical models and neural networks, provide high accuracy in approximated experimental data. Simultaneously, the neural network showed an advantage in the area of high delta k values, where nonlinear acceleration of crack growth is observed, reaching a coefficient of determination of r squared equals to 0.9994. A neural network, thanks to regularization methods, namely dropout, batch normalization, neural networks are potentially less prone to overfitting. Also, this also depends on the amount of data and training settings. In addition, neural network is more versatile and can be retrained or further trained to take into account influencing factors such as stress ratios, materials properties, etc. Whereas a polynomial model would require fundamentally different form of dependence to take into account new variables. Thank you for your attention.